The import from OSM feature has been introduced in version 29, which will allow you to import nodes, links, lane counts, speed limits, and cyclopaths directly from OpenStreetMap. To do this, you first need to create and configure your model for the area that you're going to import. And zoom into the area and choose Import Links from OpenStreetMap. Click on Create Area Selection, draw a box around the area that you want to import. You'll then be shown a preview of all the links that have been identified from OSM. You can then unpick any highway types that you're not interested in. It's worth noting that OSM does not provide units for the speed limits, so it's important to the area that you're going to be importing from. So I'm importing a UK where miles per hour is used, so my model is configured that way. Similar if you were doing it somewhere else with a different speed measurement or unit, then you should choose the appropriate one for that area. This provides a great starting point for the model development, but it should note that OSM only provides a limited amount of data. For example, does not provide information on lane points, curb points, signals, etc. So further work will be required to accurately model the road network. OSM data can be incorrect in places, so it's important to check the coding of your network to ensure it's correct.
You can now gain more control over hazard reactions using the reaction distances feature. Here we have 3 small test networks. The top 2 are urban and the bottom is highway. Each one currently has a setting of 350 meters as the signposting distance. In the event indicators, there is a new option for reacting to hazard. This will highlight whenever any vehicle is reacting to a hazard downstream. Even if they don't have to change lane, they still become aware of the hazard and react to it. In this example, we'll see that the urban links will all react around the same place, whereas in the highway they do have a spread of reaction distance. Now we can add reaction distances to this link by right-clicking on the link and clicking Add Reaction Distance, which will present us with these 3 icons. The first icon indicates where the lowest aggression vehicles will start to react to the hazard. Between this point and the next point, all vehicles will start to react to the hazard. So lowest aggression here, highest aggression here. At this point, the lowest aggression vehicles will start to consider the hazard as urgent, which means that they will start to accept smaller gaps for lane changing. Between this point, these 2 points, all vehicles will consider the hazard to be urgent, with the lowest aggression here and the highest aggression here. This gives you the ability to stretch or reduce reaction distances on urban or highway coded links. You can choose the ratio between the non-urgent and urgent reaction areas to define the point where all vehicles will start to react urgently or not. Here we can set the reaction distances so that the least aggressive vehicles will start to react early, and the most aggressive vehicles will wait until very late to react. Here we'll continue to see the urban network all react around the same place, whereas using the reaction distances above you will get a larger spread. As most vehicles have the middle aggression level, most will react around the center, with the least aggressive reacting earlier and the most aggressive reacting later. Similarly, we can change the positioning of the icons such that all the vehicles will react much earlier. This can be configured to meet your needs. This node here has its signposting distance set to 150 meters. Note that all the incoming links will continue to use the 150 meter signposting distance, other than the one that has the reaction distances applied. The reaction distance only applies to that link on approach to that hazard. Similar to normal hazard, reaction distance hazards cannot be dragged back beyond other hazards. The reaction distance is applied to this link here, and it can pass back through node 27 where there is no hazard, but it can't pass back through node 26 where there are other hazards. So attempting to drag beyond that point, the icon will get stuck. If you want to try and drag beyond this point, it becomes an overlapping hazard. So you should remove the reaction distances and place the reaction distances on the hazard upstream that you're trying to control. Another point to note is that the icons have to be in a specific order, because this is where they start to react, this is where it becomes urgent, this is where all are reacting urgently. Because of this, you cannot drag them through each other in certain directions. This can lead to issues if they become overlapped. It may be confusing that when you pick the icon, it's unable to move. It will move in one direction, but not necessarily both. If they are overlapped and you can't grab the correct one, you can use the right-click feature to pick the appropriate handle, then drag that to the required location. Ramp style merge has been improved with the addition of 2 new indicators and a ramp merge reaction factor. The 2 new indicators are urgent merge distance and critical merge distance. If we turn on the indicators in the visualizer and simulate until a vehicle approaches and enters the ramp area, when selecting that vehicle, 2 new indicators will be shown. One is the urgent merge distance, and the other is the critical merge distance. The urgent merge distance indicates the place where the vehicle believes it now urgently needs to get out of the ramp lane onto the mainline carriageway. Between the urgent point and the critical point, it will reduce its required gap in order to try and squeeze into smaller and smaller gaps as it approaches the critical point. As you can see, this vehicle has passed its urgent merge distance and is on the way to its critical merge distance, so it will start to reduce its required gap for making the lane change. And here it has completed that lane change. These points are based on the vehicle's current speed, so they will move slightly as the vehicle accelerates and decelerates. The ramp style merge reaction factor can be found in the link properties. This can be increased above 1 or decreased below 1 to achieve different results. Providing value greater than 1 will make vehicles start to consider the lane change urgent/critical earlier. A value less than 1 will make the vehicle start to consider the lane change urgent or critical later on. This is based on the vehicle aggression. Note that the urgent and critical points are limited by the vehicle's stopping distance. This means a very small factor will not be able to move the points beyond the stopping distance before the merge. Here we have set the factor to 2, in which case for the selected vehicle it has already passed its urgent merge distance as soon as it enters the link, and the critical merge distance is much further upstream than it was before. Here we have set the factor to 0.5, which has resulted in the urgent merge distance being much further downstream than it was before. The critical merge distance is still quite far upstream. As mentioned, this is based on the stopping distance of the vehicle for its current speed. A new statistical output for conjoined queues has been added to the outputs. This will record every queue found within a model along a path in a simulated second. This is output as a CSV and as part of the database. It includes the start position of the queue measured as downstream distance on the first link to the end of the queue as measured downstream on the final link. It also includes the full queue length. Conjoined queues will join across nodes where the distance between the queued vehicle across the node meets the criteria for a queue to exist, in a similar way to when using queue routes. Queues on an individual link may form part of multiple longer queues if multiple queues converge on another queued section. For example, if a queue was to form here, here, and here, 2 queue routes would be reported along this link and between this link and this link. Lanes are not taken into account in detecting these type of queue. The queues are measured using the longest queue on the link regardless of lane. This is not currently used in the Analysis tab, but has been made available for custom post-processing. Paramics License Update tool is now being distributed with Paramics Discovery, starting with version 29. This can be used to simplify the license update and installation process, and can be found in the Windows Start menu by searching for Paramics License Update. In many of the dialogues with long lists, a search tool has been provided to filter the list items. For example, in Styles dialog, you can now search for individual items. This is also repeated in Categories dialog and the Vehicle Types dialog, and similar other dialogues with long lists. In version 29, the .analysis file and .settings file have been removed. These now form part of the main model file. There is a new shortcut for Kerb curves. When the curves are turned on, you can use Shift-K to turn on the curved curves and adjust the curves as necessary. It is also now possible to search in the search box for links using the double colon syntax. This can be useful when copying and pasting link names into the search tool.